We could spend all day talking about the textbook definitions of disaster recovery, but let's be real. What really matters is what happens when things go sideways in the cloud. So today, we're going to get practical. We're going to architect for real resilience by fixing the most common, and honestly, the most dangerous Azure DR anti-patterns. And we're going to start with a call that I hope you never ever have to get.
Picture this. It's 3:14 in the morning, and that sound, that piercing alarm just cuts through the silence. This isn't some minor warning, right? This is the all-hands-on-deck signal that something has gone catastrophically wrong. Your mind is racing, your heart's pounding, and you're just trying to figure out what on earth it could be as you fumble to jump on that emergency bridge call.
You finally get on the call, and that's the very first thing you hear. Not a service is degraded, not we've got an issue in one region, but everything, the entire platform. All those systems you so carefully designed, all that code, all that critical customer data, it's all at risk. This is that moment where all the theory just meets a brutal, brutal reality.
Okay, so once the adrenaline fades and the fire is out, the real work begins, the post-incident review. And look, this isn't about pointing fingers or assigning blame. It's about understanding. We're going to dissect this failure, piece by piece, to uncover the hidden anti-patterns that actually led to this total outage in the first place.
So our first discovery, it takes us right back to the foundation, the architecture itself. On the surface, everything looked okay. They were in the cloud, they were using Azure, but they had walked straight into a classic trap, one that basically wiped out many of the cloud's most powerful built-in protections.
And here it is, the single AZ design. The concept seems so simple, but the risk, it's absolutely devastating. Think of an availability zone, or AZ, as a unique, physically separate data center. By cramming everything into just one of them, the team created a massive single point of failure. So when that one data center had a problem, well, their entire platform went down with it. The fix is really Cloud Architecture 101. Spread your workloads across multiple AZs to build that redundancy right in.
All right, so the primary infrastructure failed. It's a terrible situation, no doubt. But that's what backups are for, isn't it? You're supposed to fail over, restore your data, and recover. But as the team was scrambling to bring everything back online, they made a second, absolutely horrifying discovery.
So get this, they were taking backups, they checked that box, but they had never actually tested a restore. And that right there highlights such a dangerous assumption. A backup you haven't tested isn't a plan, it's just a hope. When you need it most, that data could be corrupt, it could be incomplete, or it could just plain fail to restore. The remediation here is absolutely crucial. You have to implement regular, and I mean automated, restore testing. You have to constantly prove that you can get your data back.
So the investigation continued, digging a little deeper into their bigger disaster recovery strategy. Now, they did have a plan to fail over to a completely different Azure region, but their choice of which region to use, well, it exposed a third critical flaw in their thinking, a total strategic wrong turn. Turns out, they had completely ignored Azure's region pair guidance. See, Azure very specifically pairs regions together within the same geography. This ensures physical isolation, but it also helps manage tricky things like data residency laws. And, this is the big one, it lets them coordinate platform updates that only one region in a pair is getting updated at a time. By just picking a random region, this team was facing high latency and the very real risk that their DR site could have an issue right when they needed it most. The fix is so simple, just use the paired regions Microsoft designed for this exact purpose.
All right, this final finding, it wasn't really about technology. It was about people and process. When the crisis actually hit, there was no clear plan of action. The team was full of smart, skilled people, but under that immense pressure, they were just operating in a state of chaos. This was the manual panic.
They had no runbooks, zero. No documented step-by-step procedures for what to do in an emergency. And that meant the recovery was slow, it was incredibly prone to human error, and just unbelievably stressful for everyone involved. The solution isn't just to write some steps down in a wiki somewhere. It's to develop, to automate, and most importantly, to rehearse those DR runbooks. You have to build the muscle memory before the crisis hits.
So we've dissected the failure. We've uncovered the zone trap, the backup gamble, the wrong turn, and the manual panic. Now for the most important part. Let's transform all these painful lessons into a clear, actionable plan. A prioritized backlog for building real, honest-to-goodness resilience.
Here it is. This is your blueprint for recovery. Step 1, you've got to fix the foundation. Get everything deployed across multiple availability zones.
No excuses. Step 2, you protect your data. Automate and relentlessly test your backups. Make it routine. Step 3, you fix your DR strategy. Align with Azure's paired regions. And finally, Step 4, you prepare your people. Develop, automate, and actually rehearse your recovery runbooks. This isn't just a to-do list. It's a roadmap from risk to resilience.
So, as we wrap this up, I really want to leave you with this one question. Every line of code you write, every configuration you set, every single architectural choice you make, it's all part of a larger story. I want you to take a hard, honest look at your own systems. What story are they telling? Is it a story of resilience, ready for the unexpected? Or is it a story of hidden risk, just waiting for its own 3 a.m. wake-up call?